So for each of these problems, I have directions for how to use your calculator to check these. We're going to look at those directions after we write some functions. So I'm going to come back to those calculator directions. We're going to skip down to where it says exercise 2. So it says write an equation for each trig function. Let's move a little bit first. Write an equation for each trig function in the middle column in the table. And we're going to leave the last column blank for now. So looking at my first graph, the first thing I want to do is determine if the function is a positive or negative cosine curve. So I'm really looking at the y-intercept, which is right here. Midline would be sine. This is not a midline. It's at the maximum, so this is a cosine. And max, we know, is positive cosine. So if you look back at those rules in the last page, this is a positive cosine graph. The next thing I'm going to do is try to figure out what the midline is. This one is pretty obvious. Remember, if I can't tell where the midline is, in this case it's y equals 1, I can add the max plus the min divided by 2, or find the average of the max and min, which is also 1. So the midline is 1, and that's going to be my d value. So far, and I could use any function notation to say what to use. I have a positive cosine graph. I'm not going to write a plus sign. I need something in here. My midline, I know, is my d value, so I'm going to write a plus on there. So the next thing I find, I just did step 2, is I'm going to determine the amplitude. So my amplitude here is 2, and we know that goes in the front. Now, based on what I decided here, I'm going to leave this a positive 2 and not make it a negative 2. So that's how you decide the sign on that A value. The next part, maybe the trickiest part, is finding the period. So I usually trace the graph out for one cycle, which is here, and I see the period as pi. Now we know from our formula we don't directly put that number in as the b value. There's a relationship between them though. So we had this formula, period, right? So if I solve this, I want to find the b value. I wrote the wrong thing here. Sorry. Our old formula was the period equals 2 pi divided by b, and that still is the correct formula to find the period. If I solve this for b, which is what I'm trying to find here, I would multiply both sides by b, and I get b times the period equals 2 pi, and solving for b, we then divide by the period. So it actually works the same way. If I want to find the period, I do 2 pi over b. If I want to find the b, I do 2 pi over the period. So since I think my period is pi, to find the b value, I do 2 pi divided by the period, and so I get 2. So in here, I'm going to write 2, and whatever variable I choose, I'm just going to write s. So in this first column, we're not going to shift anything. Okay, so we'll talk about that next. We're just going to just say is it sine or is it cosine. Looking at the next one, I start on the midline. So I am working with a sine graph. I go up first, so this is a positive sine graph. That midline is 3. Okay, so my d value is 3. So to set this up, we have something with a sine, and then parentheses, and then I would do a plus 3 at the end. Looking at the next part, we are going to find the amplitude. The amplitude is also 3. We want a positive 3. So I do not need to write a plus sign, but I kind of want to. The period, if I trace this out, takes all this distance till the sine value would start to repeat. And that is, and it's hard to see here, but that is a 4 pi. So to find my b value, the b value is 2 pi divided by the period. So I get 1/2. 2 over 4 is 1/2. So that's my graph. So now that we have a couple graphs, I'm going to show that these work, or show how to check them on the calculator. So we're going to go back up to these directions at the top. We'll check the first one and the second one. So the first thing you want to do is make sure that your calculator is in radian mode. And for graphing, we are always in radian mode. I don't know where my cursor went. Oh, there it is. Okay. So, mode, I was in degree, make it go to radian. I'm going to type in 2 cosine of 2x plus 1. Now I want to see if the graph matches what I see here. So I'll usually set the window to what I see. The last number I see is 2 pi, so I'm looking basically for this chunk of the graph, and my y values go from -1 to 3. So what I do on my window is I'm just going to make those numbers match. So my x is 0 to 2 pi, and you can type in pi here. That works fine. You'll see it converts it to a decimal. I'm not going to worry about the scales for now. And then my y values go from -1 to 3. So if I graph this minus this chunk on the side, I should see that graph. And I do. So I know I found the correct equation. Looking at the next one, we have 3 sine of 1/2 x plus 3. My window this time looks like it's -1 to 6 for y, and it goes out to 4 pi for x. So I look at my 4 pi, put that in, I go -1 to 6, and I see that sine curve. So I could do that for the remaining 2, and really it's just about setting your window. If I wanted to match up this scale and make my lines exactly the same, so this is a pi over 2 for my scale, I can put pi over 2 in here. And then you'll see the exact hash marks that match up with this. So that's extra, but that is something you can do. So those directions are up here as you go through. One more thing I'll show is if you're just not even sure what to use for your window, if you do a zoom trig, which is zoom 7, it's going to give you a decent viewing window. If I look at my window here, it goes from -8 to 8, -4 to 4. So that is a standard trig viewing window, but usually we just want to set the window ourselves. So let's finish up with our last couple graphs. So this one, first decision, what type of graph do we have? We are starting at a minimum, so that is a negative cosine graph. My midline is 0. So this function is going to be a negative. I'm going to leave a space for my a value in case I have one, and nothing's going to go at the end because I don't have a vertical shift. The amplitude is 3, so I put that 3 right in there. So we can see the amplitude is 3. That's why if I had seen this equation first, I would say, oh, my amplitude is 3 because I take the absolute value of the negatives. The negative comes from the direct, or where the graph starts, and determining where the negative goes. So my period, again, is 4 pi. My b value is 2 pi over the period. So I have another one that has a 1/2 in the front. So we're going to go to the next page. I'll just do the top one, and then we'll just start to talk about these transformations. So looking at this one, this time I am starting on the midline for my y-intercept. It goes down first, so I have a negative sine function. My midline is y equals -1. And I'm going to do all the quantities here. My amplitude is a 2. And my period, a little harder to tell. My period is an 8. Okay? So my period equals 8, which means my b value is 2 pi over the period. So that's a pi over 4. So those are all the qualities I need, and now I'm going to try to figure out where they go. So in the front, I want a negative sign, then the 2, and then sine. So I have -2 sine. At the end is my -1. And then in here, this is the b value, so I have pi over 4, and then my x. So we see, remember, when we have a rational period, when we have like an integer or something for the period, like 8, we're going to end up with pi in our b value, because those two, the pi has to be somewhere.